Hello everyone, and welcome to this new tutorial on flooding simulation using OpenTelemac. This video is going to be divided into several parts, each focused on a different subsection of the study. In this one, we're gonna go through the process of creating a mesh and interpolating topographic data to it. So, let's begin by creating a new project. Click on XYZ tiles and select OpenStreetMap. Now, we are going to change the coordinate reference system, CRS, consistently with the study we are going to do. In this video, we're going to study a French river as an example. So, we're going to set the CRS to EPSG 2154. Be careful to not change the layer CRS of the OpenStreetMap layer or any XYZ layers. The OpenStreetMap CRS is EPSG 3857 and should not be modified, otherwise it will false the coordinates, so leave it as it is. The river we're gonna study for the flooding is called Yvette and is a little bit on the south of Paris. There it is. At this point, I should introduce the CATS plugin, Q4TS, we pronounce it CATS. This is a plugin developed by EDF and that allows to create a mesh and to interpolate on it data in order to give it to OpenTelemac. In this video, we are going to use a Docker image that already includes CATS. This Docker is going to be available in the description. If you look in the settings, you can see that this CATS plugin actually calls Salome and OpenTelemac in order to create and process the mesh. So let's start by using the Create Mesh module. On the contour layer section, you can see it is actually empty. There are several buttons on the right, but we are mostly going to focus on the plus button here. As soon as you're going to try to create something, CATS is going to ask you to save the data in a GPKG geopackage file. Select a place where you want to save the geopackage. You'll have to name this geopackage and also give a name to the project itself. Once this is done, you should be able to draw directly on the map. But just for the sake of the example, let me show you how to toggle on and off the draw option. Let's now draw the contour of the mesh. Left-clicking on the map will create a new point. A closed line will be generated with all of the points you created so far. Once you are done drawing, right-click and press Enter to finish the contour. Just like so. If you ever want to change what you've done so far, after you save the modifications you made, you can go on and toggle again editing mode and then click on this button. Then you'll be able to move points you already drew before and create new points in the middle of a line that join two points. Let's make it a little bit more circle-like and save. Finally, let's toggle off editing. Now we have created the contour layer. We can create other types of layers, such as the island layer. The island layer is basically to draw areas that are not going to be meshed. The button on the left allows you to add more island layers, while the button on the right, the plus on the right, allows you to draw exactly like the contour layer. For the sake of the example, let's draw a small island layer. Like that. The constraint lines layer allows to force the mesh to make nodes on a line that you're drawing. For this example, we are not going to use it. Finally, the refinement area layer allows you to draw a polygon in which the mesh is going to be finer or coarser. Let's create a refinement area on the riverbed of Yvette. Now, when you're going to press right-click to say that you're done drawing, a window will open and asks for the characteristics of the mesh you want inside this refinement area. Here in this example, I don't open this window. Instead, I'm going to show you how you can open it once you have closed it already. Click on the Refine layer, right-click and select the Attribute table. Open it. Then, click on the Toggle Editing and you should be able to directly state what you want. For this example study, we're going to ask for the minimal size of an element to be about 2 meters and the physical and maximum size to be about 8 meters. Now if we look below the Refine layer, there are other minimum, maximum and mesh characteristics that we shall enter. For this study, we're going to take a minimum mesh size of 10 and let's say a maximum mesh size of 50. The growth rate is some parameter that defines how rough the transition from smaller to bigger mesh element is going to be. Click on the little 3 dots button here and save a temporary mesh. Then you can click on the Run button. You're going to have to save in the geo package every element you have created and you're using to create the mesh. The CATS plugin is then going to call Salome algorithm and create a mesh. On this newly generated mesh, we can clearly see where are the island and the refinement layers. Here on the left, next to layer, you can pick or unpick the layer that you want to see, and you can also drag and drop layers to make them foreground or background. We are now going to interpolate some data to the mesh, starting by the bottom and the type of terrain that I downloaded from the IGN, Institute of Geography of France website. Let's start with the bottom variable, or the topography of the mesh. To do that, we are going to use the Interpolate point cloud module of CATS. As you can see, there is a section called Input Point Cloud. If you try to click on it, you can see it requires a .xyz types of files. Let's try and load the topographic data I downloaded. Go into Layer and add a raster layer. Select the data. Here, these are all of the .asc files. Then press Open and click on Add. They are all going to be loaded on the left, and we are going to look for the tiles where the mesh is. Let's drag and drop the mesh in front of them, and we see that the mesh is on this tile, so we can delete all of the others. If the mesh was on several tiles, we could use the merge function of QGIS that can be found in Raster, Miscellaneous, Merge. Here we don't need it. Now we're going to convert this .asc tile into the correct .xyz point cloud in order to use the Interpolate point cloud CATS module. To do that, let's go into Raster, Conversion, Translate, then select the tile in Input layer, and in Converted, click on the 3 dots, Save to File, and here on the Files of Type, select XYZ. Then give it a name and save. You can now press Run and the conversion will occur. Now that we have the converted XYZ file, we can remove the .asc one. Now it's important to realize that XYZ files are simply points. Here we don't see it because it is displayed as a polygon, but if you go into Layer, Add Layer, and then Add Text Layer, you can choose it, select the XYZ file, you can put a custom delimiter and select it as a space, then unpick the first record as field name because it's not the case here, and select the X, Y, and Z coordinates as field 1, field 2, and field 3. Put the coordinate system correctly and click on Add. As you can see, these are just points. Now we can go into the Interpolate point cloud module of CATS. The input mesh must be mesh Evet, the one we created earlier, and select as an input point cloud the .xyz file we just created. And don't forget to change the delimiter into a space, as here the datas are not separated by a comma. Finally, save the output mesh with interpolated data. I call it Evet bottom here, and you can press on the Run button. And there you have it. We see the mesh with interpolated topographic data. If you go into Property, you can see that now the mesh has a bottom variable that has been added to it. Thank you for watching this first part of this tutorial. In the next video, we'll be interpolating other types of fields to the mesh, such as water levels or type of terrains. In the meantime, feel free to subscribe, and I'll see you for the next part of this tutorial. Goodbye!